Hi everybody, Patrick here from Engineering Shock Electronics, engineeringshock.com. This is the Epoch Learning Center Project 16, Plotting Audio Waveforms. And if you haven't already, check out the Kickstarter link below. For this project, we're going to use chip A. We're not going to use the LCD, we're going to use the serial monitor and the serial plotter. And this is a very, very small and simple project. I'm going to try to knock off some of these blocks so that we can get into some more complicated projects soon. And so for this project, we're going to use the little microphone circuit. Now I'm going to zoom in just so you can see what I'm doing for the hookup. Here's the microphone, and there's a little amplifier circuit right here. And there's a 2-pin header right here. The top pin is labeled A0 in brackets A. So the analog 0 pin on chip A. And the mic output, MIC. And that is the MIC output is the output of the microphone. And that is an analog signal that varies depending on how much noise is in the room. And we're going to try to get an audio waveform out of this. Now the chip can't sample fast enough to make it look like a proper audio waveform, but you'll see what we can come up with. We're also going to plot data to the serial monitor. So all I need to do for this project is connect a 2-pin header or jumper over that line. And we're using chip A, so we want to make sure that we are programming chip A, so we want to make sure all these 3 headers are on the left, not on the right. If we switch all these jumpers to the right, then we're programming chip B. In any case, what I'm going to do is I'm going to upload the code and we're going to look at my computer screen. So I'll go to Tools, Serial Monitor, and what we'll see is just a bunch of numbers. Most of them are 0. We'll get some noise. If I start yelling, it's going to make a huge difference to these numbers. I'm going to do that in just a second, but we're going to see just noise essentially until I start speaking in the microphone. Maybe 20 or 30 max, but usually closer to 0. So I'm going to start talking to the microphone. Hello, Mr. Microphone. What do you say? So the numbers obviously changed and then back to 0. So it's sampling so fast, but not fast enough that you'd want for an audio chip that samples thousands and thousands and thousands of times a second. The Arduino takes, I think it's something close to 5 microseconds per sample. You'd want faster than that. In any case, I'm going to stop this and I'm going to open the serial plotter. Now right now, we're seeing essentially noise. This is 0, and we're seeing a maximum of about 32 out of 1023. So this is just room noise. And so if I start talking really loud, the scale changes, but now it's changed back. So 32. If I start talking really loud, now we're at 60. So the scale changes. So what I'm going to do is I'm going to start talking into the microphone again. Hello, Mr. Microphone, what do you say? And then the scale changes back because we're back to about 32 at max. 0 and 32. If I start talking to it, I imagine it's going to go up to about 500. Hello, 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 hello. 800. So that's it. Very simple project, very simple video, and this is the audio waveform. Again, it doesn't look like a fantastic audio waveform, but this is essentially just a way to show yourself your voice. So now I'm talking kind of loudly, so it's all over the place. I'll be quiet again. And the scale changed back. So that's the serial monitor, the serial plotter. It's all over the place because I'm talking right now. If you start playing music, I would do that, but my children are actually asleep right now. So if playing music would actually show a much different output than this. But this, when I'm being quiet, just room noise. It's actually a very, very low voltage signal. But when you start speaking loudly or talking into the microphone, we're not talking about 0 and 32. We're talking about 0 and 800. So the scale constantly changes because this is going so fast. Now, if I put a delay in, it would make a big difference here because it would start sampling much slower, but it also wouldn't capture as much of the audio waveform. So thanks for watching. I hope you have a wonderful day, and if you haven't already, check out the Kickstarter link below. Take care, everyone. The project page is being updated as soon as this video is done. Take care.